think it's working. I'm not sure. Oh, I still have Mystery Science Theater 3000 on in the side. How are you, Ben?
Very good. Just trying to rapidly
Get
post
ready
on my
for a
LinkedIn.
webcast. Yes.
Yes. Oh, it's
It's
crazy
Friday.
times, but I'm well.
Good.
Wearing my PCEA swag. I put this on today, thinking of you, dear audience.
What is
Because
PCA?
PCEA, the Printed Circuit Engineering Association.
Okay.
Free membership. You should join. If anyone is ever going to design printed circuit boards, you want to be a member of this organization, because the people that run it and put it together are really some of the most knowledgeable, most experienced people specifically about printed circuit board design and manufacturing that you'll ever meet. They're for the most part, they're the people who've been doing it a long time, and like people like Rick Hartley,
right?
Stephen Chavez, or Steph Chavez as he goes by often. They're all from all different backgrounds. Some have used PCAD, some have used Altium, some have used Mentor, and so it's not really about the CAD software. It's about how to design a board and know it's going to work. It's going to be to spec. It's manufacturable, and it's not going to cost too much, because you're always fighting with any kind of circuit board design. And today it's easier for hobbyists, to be honest, because we have services like PCB Way. You can mention that again too, Osh Park, and others who do low cost panel share kind of things. Well, when you're sharing a panel, you're working with a fixed set of constraints that are really the lowest common denominator for getting something made that actually works. So if you work to their constraints, the only thing that'll stop your design working is that you didn't actually design it right. Like, you didn't know what you were doing and didn't connect everything right. So it has gotten easier. But anyone who has ambitions to be a professional circuit board designer, you're going to wind up doing some pretty crazy stuff. Like, you imagine an electric vehicle. What has to go into an electric vehicle electronics wise? You're mixing very exceedingly high voltage, and not exceedingly high voltages, reasonably high voltages, like several hundred volts DC, with exceedingly high currents and multiple quadrants, and you're trying to control all of that. I just got your mic noise again there when you stood up and sat down. You're dealing with that, but you have very sensitive analog sensors and stuff everywhere as well, and you got to keep the noise out. So just joining something like this and going to chapter meetings, it doesn't cost you anything, but you'll always learn how to be a much more successful layout designer. So I only had that on my mind because next week is the PCB West conference in Santa Clara, and this is one I've been to many times in my career. So I'm looking forward to going there again and meeting up with some old friends. Last year was the first year back in person, and it was lightly attended, as you might imagine.
Right.
This year we're expecting a lot more people, and it's going to be busy. It's going to be awesome. I'm actually doing 2 classes, one on printed circuit board antennas and another one on RF and microwave printed circuit board design, which is a full day class. So I've been, as part of the reason I couldn't stream last week with you, Bill, is I've been trying to get as prepared as possible. I have done these classes before, but it's I always like to, update, run through, make sure I'm going to deliver something well. So I hope I can. Yeah. So anyway, that's just what I was thinking about. But today, I also had a hectic week because I was working under the gun to get something finished for Autodesk, actually, who I used to work for until February. One of my friends there, Jorge, hope you're watching, brother. Thank you for getting me involved. They have their annual user conference. They had it this week. It's called Autodesk University. I've never been to one in person. The year I was working there, the 2 years I was working there when they had AU on was during lockdowns and COVID and social distancing. So it was all done virtual.
Right.
So I never got to attend live, but it looks like a pretty darn awesome event with thousands of people showing up. But Jorge is like the electronics community manager for Eagle and Fusion 360, and he's one of the friendliest people you could ever possibly meet. So is Edwin, actually, Ed Robledo. Hi, Ed. Hope you're watching. Those guys were the core team for Eagle in America until they were acquired by Autodesk, and they're still there, still supporting it. So Jorge designed this really cool board that's going into their badge for the people who paid extra, the people who paid a few $1,000s to go to the conference at the highest level, got this extra, what they call a factory experience. And they designed this badge to go on their lanyards. I've soldered a little reset button onto that because I needed that for programming. But they went through the whole thing. It wasn't just like we've been to. Well, I'm still getting a lot of that noise, bro.
Okay.
They didn't just design the board and have people attach it to a lanyard. They actually had the full thing. Like they would go in, they'd see how the design was in Fusion. They could look at it. They could look at all the different assembled parts, including an injection molded case and optional extensions that have been designed but weren't built yet, that plug into these headers on the sides. And they're like, hey, we need some help. We don't have anyone on our marketing team who's got any of the embedded background. And what we wanted to do was design this board. We had to design it with an RP2040 because it's basically the only microcontroller anyone can get right now.
Right.
But we want it to work with Microsoft MakeCode Arcade. And I don't know if anyone watching has played with MakeCode. It's actually, I've seen things like it before. You've all probably heard of Scratch. It's a very similar kind of thing. It's basically a graphical programming environment targeted at kids and students who've never done any logic or programming before. And MakeCode Arcade is a really interesting one because it targets microcontrollers on boards that you can basically design your own, but there's a lot of boards out there, like from Adafruit and others. And they just stuck with a standard, or kind of de facto standard ST7735 display. So if you use that, they have a basic set of rules for how to create and define buttons and GPIOs, and then everything else you can basically do in MakeCode. It's like a web browser tool that lets you use Blockly to do block-based programming. I'll show it to you in a sec.
Okay.
But the cool thing is they have all these samples, and the whole system is built with on top of a kind of device abstraction layer, or runtime library called Codall, which is developed by Lancaster University in the UK. It's all in C++, but so that's pre-compiled, and they link to that to get all the services it provides for all the IO drivers, display drivers. It's basically a lightweight operating system. And then on top of that, they've got this layer that uses JavaScript, or a superset of that called TypeScript, which I've never even heard of until I was in this project. And I'm like, this is a new world. Like, so imagine JavaScript with extra functions and libraries that come with it that give it more capability for embedded systems, right? And on top of that, they have a web server called PXT. I forget what that stands for. Programming. I don't know. It's on their GitHub. I could probably share my screen actually and show you. So I'm about to get to the infinite. Well, actually, I'll share my other monitor because it's a bit lower resolution. It'll look a bit better. So I'll just drag all of this over there. If I, let's see, Microsoft PXT. I'm looking for the right tab to drag over. So these are some repos on GitHub I've been getting code from and customizing and working with whilst in this project. And this is what MakeCode looks like. Okay, so so for example, they have this tutorial Galga. It's, of course, they have to rename it because the name is Gallagher is a trade name for a commercial product.
Okay.
Right, but this is my version of Galga, and it has a simulator, and all of this is running in my browser locally, so it's really fast. And then, so what this does is it compiles like all these blocks are actually defined in they call it JavaScript because students know or have heard of JavaScript. Yeah, it's complaining about a GPIO thing. That's actually a bug in the simulator. I don't need to worry about it. So it looks like JavaScript. It's really TypeScript, which is a Microsoft superset. And then it's got this asset builder that lets you draw all your own sprites.
Okay, well, that's cool.
And backgrounds and any kind of graphics, animations as well. I have another project I'll show you in a sec like that. But I'm looking at this and going, no, I get this. That the whole system is for educators. This whole thing is about helping teachers, science teachers, math teachers teach logic to children and to, in some cases, first-year university students are even using this.
Okay.
But there's so much automation in this that it takes a lot of that, all that low-level stuff. So we have basically it's 3 layers of abstraction. We have Codal, which is this mysterious OS. It's open source, so if you want to get into it, you can get it on GitHub and you can start contributing. It's all in C++. I was trying to encourage the JPster a day or two ago on Discord to get involved, but he's like, C++, no, like he's fully into Rust now, so I get it. Rust is a great language. But here was the problem. MakeCode, Microsoft PXT, MakeCode, whatever it's called, like they call it their own language or their own name for it on the back end is PXT, right?
All right.
It's all open source. Yeah, Programming Experience Toolkit. So you can basically build this and download it, or you can download it or check it out, clone it locally. You can build and run it in like 3 command line commands. And then you have your own instance of this running in your own browser, entirely served locally, or you can use the ones they have publicly served online, which is what I'm showing here. So there's 3 layers of abstraction. You have a website that gives you this programming IDE, for want of a better term. Then under that, you have that compiles to, or it gets put into an emitter that compiles and links to, it compiles it to binary for the target device. They currently target ARM Cortex-M only, which means the Raspberry Pi RP2040 is a dual-core ARM Cortex-M0 Plus. They also support, out of the box, they support SAMD21 from Atmel or Microchip. And STM32F4, which is a Cortex M4 or M4 Plus. The problem is up until somewhere around May or June this year, they didn't support the RP2040 chip. Someone on the Microsoft team who's involved with this was busy behind the scenes doing an initial implementation and getting it supported in CodeAll, getting it supported in the PXT framework. And so the reason Jorge reached out to me and asked for help on this project is like, we want you to actually port Microsoft MakeCode Arcade to the RP2040 and our board. And I'm like,
Wow.
damn, I'm probably going to have to subcontract some of that because I'm not a compiler guy. I'm not a library guy.
Yeah.
Everyone knows me from the PCB industry. I'm definitely a very experienced PCB guy. What people may not know is my actual training and all the stuff I did for Altium in the early years was embedded. I actually joined Altium to do FPGA and embedded C programming stuff when they were selling FPGA stuff.
Right.
And that all changed. So I had to adapt, and I like boards too. I designed circuit boards from a pretty young age. So I thought, well, this maybe, I don't know if I can do this. I really had big doubts. And then I found out they put me in touch with some people at Microsoft, and they're like, yeah, actually, this is perfect timing. We've been working on RP2040 support. You'll be a good test case.
Good.
And so I didn't have to port this operating system to a new chip. That would have been impossible. In the amount of time I had was only a few weeks.
Right.
So it was still quite a challenging project, but we got it over the line, got the board working. The documentation, unfortunately, in some of these open source projects, even if they're sponsored by big companies, the only documentation in some to do with some things is the code itself. So I had to spend a lot of time. I read a lot of docs, but I also had to spend a lot of time digging into the three different layers of abstraction and looking at code and seeing, well, there's this plugin for the microbit that enables the user to declare a block for controlling pins. In other words, reading and writing digital, reading and writing analog, PWM. We need all that. They haven't implemented that yet for Raspberry Pi 2040. They've only implemented enough to build a board that you can play a game on. That's similar to the one in the simulator. But we actually are going to need GPIOs and more control over the pins because of the way this board was designed by Jorge. He, like for example, the push button switches are pull-up push button switches with 100 kΩ resistors that pull down. And that meant I had to find a way to declare, even in MakeCode, that the pins the GPIOs they were connected to had to be configured inside the Raspberry Pi 2040 chip to have a weak pull down inside.
Pull down. Yeah. I'm from the days where there was no such thing as a pull down. You couldn't get the math to work on TTL.
Yeah. So, and there were some other things, but overall it turned out like I was pretty stressed, but we got it across the line. It turned out good. People who had the factory experience, the feedback I got from the marketing manager who was running that whole thing was that the people who attended loved this thing and were really thrilled that they could then take it home later and reprogram it to do other stuff with MakeCode. I don't know why this should be playing. Oh yeah, it's again the simulator's erroring on my pin thing. I could comment that out in the code for the simulator, but for the actual board I have to set that pin pull down. And so, and this is just what it looks like in TypeScript. They even have debug here. You can simulate using this and it'll actually step through the code and highlight each block as you're single stepping. So it's a pretty decent
cool.
IDE for something that looks like a cartoon and was targeted at children.
Right.
I'm actually kind of impressed how this whole thing, it's mature too. It's been around for quite a few years now, but like I said, they only just were starting to work on support for RP 2040. So I had to run blind, and so I'm intending on making some walkthrough tutorials for this for the Schematica channel, so other educators, if they need help getting it to work, can do that. So first I got it going. Let me join with my phone.
Yeah. So how's my audio now? People said I got loud there. I'm on a different microphone now.
It sounds good to me.
All right.
Yeah, I'm just going to jump on StreamYard on my phone as well, so I can have the other camera view. Oh, actually, that's going to take too long.
Right.
Let me just grab this.
Good. Okay. Yep. Thank you, everyone, for the level check.
So this was the first. This was my, like I was using some of my old Altium prototyping stuff for an Autodesk thing. Isn't that ironic? Sorry, guys. But it's what I have on hand. I had a bunch of these ST7735 displays in a box, but they were all just flex connector. So I had to spend a bit of time putting this on a, like it was, to get this working, it was faster to do this than to order display modules from Adafruit and wait for them to ship.
Right.
Until I received this from Jorge. This came late in the game. They finally had these prototypes, and then about a week later, a week after I confirmed that this was functioning with the software, that, oh, come on. My daughter is so demanding. She doesn't understand. But that's okay. She's 13. You know, 13-year-olds, the only thing in the world is them.
Is that decimal or binary? Decimal or hex when you say 13?
Aha, decimal. So this was my little test program, and I was able to confirm it working just using a Pico module. So that's pretty cool.
Yeah.
I got really thrilled when I saw the display actually functioning and doing what I told it to do. Yeah, I got really excited. I thought this may be possible.
Right.
And so, yeah.
Very cool, man.
So then we had to, let's see if this one's actually running the code. This one may not be programmed. Yeah, this one's not programmed. I'll grab the other one. The original hardware design, the team had assumed, because they put the debug header on.
Right.
They'd assumed we'd be able to use a debugger to program and everything. Yes, I'm playing a little version of. Oh. So, yeah, if you want a cute little retro arcade system, and there's a lot of projects in GitHub, all over GitHub, where students have actually rebuilt a lot of the games that we know and love, and they'll run, like, this system so far is only using one of the two cores in the RP 2040. Again, it was up till now, it was only targeting STM32s, which you can't get anymore. Right. And that they weren't dual core. There's a lot of things about it that are inefficient. Codal uses software for floating point, right? So you're not getting the benefit of things like in an STM32F4. If you could buy one, right, you got a floating point unit. You're not getting any of that, and it still runs. It'll still do all this stuff make it very playable. So yeah.
Cool.
So that's kind of been my week, and it was hectic getting it working. I did pull one all-nighter. A lot of the problems were in configuration. They have this. This was one of my gripes about not having good documentation, right? Let me add this back in, and I'll show you what I'm talking about. And I did get help from the Microsoft team who know this in and out and are part of the original sort of development crew for this whole platform. But let me see if I can find it. So yeah, they were very helpful, but they weren't always available. And what they'd done was that they were using, let me go back there because there might be a link to, they have this thing called the CF2 patcher, right? So what you have to do, and this is a very sparse page. It doesn't say how to load. Oh, it does. Yeah, drop a UFT or binary file above to see its configuration. So with all these different boards you can get, like different boards from Adafruit and whatever, and they all have different pin configurations, GPIOs and all that. So you have to basically take an example that they already have. Let me see if I can find my config here. I know I can. It's in my Dropbox folder somewhere. Okay, I have this. Sorry, I'm stalling a little here while I'm finding the right file.
I can do a plug while you're doing that if you're interested for something.
I'm almost there. Just give me 1 second. I've just got to get the right GitHub folder on my local drive where I have a. Yeah, so basically, let's see. Here's a sample config that they give you for the RP2040. So this is kind of the syntax. Now, the documentation for this, what this does is it converts a file that's written like this, just text, into a series of routines that get stored in the chip at a certain memory address. And anytime Codall wants to do I/O or plug in the right address for a particular pin or a particular peripheral for its driver, it goes and looks at that and gets it from there. And that has to be loaded using this UF2 bootloader, which is something built into the Raspberry Pi chip. It's something that was kind of, like a USB bootloader, basically. And so, but the documentation of, okay, so what are all the things I can declare and what are they for? Again, the only documentation for it is this header file that's used by the system. And so you basically have to go through and use trial and error and look at what other people have done.
Wow.
And look at some of these are obvious, like the display, MISO, MOSI, reset, S-clock. I get all that. But there's two pin definitions for sound. One says pin _ audio _ amp, and the other is pin _ jack _ SND. And SND isn't, like, they should have made it sound, like spell the thing out. So if the only documentation is source code, make it self-documenting, please.
Right.
I mean, for God's sake, people. Anyway, just one of my gripes. Software developers, I understand, like, you're busy and you've got to type a lot, so you like things really terse. I get it. But, you know, leave a trail of breadcrumbs for those who follow, please. Anyway, we got it over the line. Oh, those are still there. That's why it's now. That's why I'm getting the simulation error. Those should actually be up in that if block. That tells the simulation to ignore those pin pull-ups. Now I can run the simulation. How about that?
Oh, wow.
I'd forgotten that. Oops. But there's some if what this got me thinking is I can do anything with logic, GPIO, sensing, analog input, you know, within reason. I'm not going to do any RF or software-defined radio with something like MakeCode Arcade, but this could actually be a really good platform for anyone doing home automation or any kind of automation where you know logic, but you're not a software developer, and you just want to get a board with a microcontroller and a bunch of relays and make it do some stuff to make a machine run or control lighting in a factory or anything like that. I just thought this is not just a decent educational platform for retro gaming as a target. You have a display. They have all sorts of menu systems. You can. It's just really cool, and you've got animation and everything. So you could use this to put together pretty decent little industrial computer systems for other apps as well. So yeah, I mean, I wouldn't ever have expected this to come from a company like Microsoft, but I guess they decided they wanted to embrace the open source community some years ago, and this is one of the results of that. So I'm pretty impressed, to be honest. It needs more. It needs more people in the community contributing to it to support additional hardware. So I'm considering how I might help with Codor, for example, on the back end to enable multi-core support. Like, it's super easy to use the 2 different cores in Arduino IDE. If you're using a Raspberry Pi 2040, you just have 2 setup and 2 loop functions, and you're using 2 cores. It's dead simple. Of course, that's limited, and it's at a professional software engineering level, you wouldn't do it that way necessarily, because you need more flexibility for real-time systems. But as a basic way to get going, this is a pretty cool thing, I think.
What all do you have to do to get to this part, though? That's how usually it's like, oh, I'm missing a library. Oh, I got to set a variable. And when you're done, it's like, oh, I wish I'd written all that down because I got it working, but how do I get it working again without going through everything?
Yeah, well, I've been through it enough. I'm not going to forget. But like I said, I'm also going to document my experience for other people and put it on YouTube. But so basically, I had to get intimate with the design, which is like you should be anyway. If I go in here, I should have opened this before we started streaming. Sorry, this will be a little bit slow to load, but this is the project in Fusion. And just once we've looked at that, I could show you the injection molded case and all that kind of stuff. But basically, they also had, what they pointed me to was, let's go back here for a second. They also have not just the binary patcher. So I have to use this to define the pinout of my board. So it's like working with OshPark. It's like working with PCB West. If you want a low-cost prototype, you're sharing panel space, so you have to work within the constraints of what they're offering. And in those cases, you're using a fixed layer stack. You have to use their layer stack. You can use 2 or 4 layers, say.
Right.
And it's their layer stack. So you load that into your KiCad or Altium, whatever you're using, and that's what you're designing with. And their design rules, you download and put them in your DRC check engine. And that means you're doing, for a low-cost board, you're doing 5 mil trace in space, when really if you just went direct to a factory and spent more money for a commercial production run, you could easily and fairly cheaply go down to 3 and 3 today. right? But because you're willing to work within the constraints they set out, then everything's going to be fine. And it's the same here with this software on an embedded system. You can design your own board, but you have to work with their way of configuring the IOs. And then I had to, as I mentioned, resolve other issues like pull up versus pull down push button switches. And all of that can be resolved pretty much in software as long as you've configured things right. But they did have a guide here. If I go, they have this repo in GitHub for hardware designs, and these are also open source. So they give you this repo, and Microsoft themselves have designed sample hardware designs that match what you see here in Arcade. If I go back in here and you see this simulator here, they actually have a product you can get that's a little board that's inside a plastic case like this, right?
Okay.
And that those boards, they actually give you the designs here in GitHub, so you can download them, open it. They are done in Altium, but they have all these instructions. And I say, if you're going to design your own board, this is what it needs to have. I should open those too. Let's see. I've got Altium open here on the other screen as well. Let me see if I can. It may have been open on my laptop and not this computer. And I started designing my own Pico badge in support of this as well, which I'll do. I'll use on my channel when I do the tutorials. Yeah, I guess I don't have it loaded here. So let me open, because I know I got them from GitHub. Dropbox. Let's see, GitHub. Am I crazy for cloning stuff off of GitHub into my Dropbox folder, which is just cloning it again into Dropbox? Probably.
Well, I assumed that you're spreading it amongst your different workstations, much like you had a local LAN.
That's the exact point. It's like this is my massive high-powered desktop at the office for doing crazy number crunching,
right?
CAD work, but I also want to open the same things at home on my laptop.
So my Altium runs really slow because I mount the projects on a network drive. And after you do your out job, all of those files it generates, when you go to save to server, even though you're not saving them all to server, it takes my laptop a minute and a half after I click save to server before Altium responds again.
Yeesh.
So
yeah,
I'm unusual that I mount I never mount locally. It's always mounted across the network.
Yeah, so this is their main sample design. It uses a STM32F411. They don't include everything here. They give instructions in the notes, and they mention that audio is done using PWM. So you need a low pass filter. Need a low pass filter and an amplifier if you have a speaker on board. So they give you all the information you need how to design your own board, and basically it's like, well, you would copy this one. Problem is, no one can get STM32F411s anymore. So, and the other one that they supported was a SAMD21. And what they don't give you with this hardware project is a sample config file, because depending on the target processor, the way you do it is different. I mentioned the config keys header file, and I mentioned the CF2 and the UF2 and that CF2 patcher. That's all for the RP2040 chip, because it has to generate a UF2 file that you bootload into the USB bootloader. Well, these other CPUs, the SAMD21 and the STM32F4, don't do it that way. So for this one, you actually have to create a header file. You basically use you have to program in its own bootloader that is designed to work with MakeCode Arcade. So it can download higher layer code to the chip after it's got the basic bootloader installed. And in the bootloader, you have to configure all those GPIOs and names of variables to be those different pins and such. So yeah, I mean, what was that comment?
Oh, I forget. Oh, somebody was telling me not to use a network drive. He's got a better system, but
I would have said that too. I used to store things on network drives when I was working at Altium, and it got painfully slow.
Yeah,
I just stopped, and so
it's like anything. It's a compromise. I'm managing my risk versus my inconvenience.
That's true, but that's the other thing. Like, people are often cloud averse with CAD data. I get that. It's totally cool. Nothing wrong with it. Just make sure you have a backup. Cloud data is a blessing and a curse with backup, because if I'm storing something in GitHub or Dropbox or Altium 365, on one side, like, I know it's there. As long as I've committed to it, my whole machine can crash. I can lose the hard drive. It's all still there. It's safe.
Right.
But if I make a mistake as the user, if I screw up by overwriting something or deleting something I didn't mean to delete, that can replicate as well.
Right.
I remember at Altium, probably 10 years ago, I was in the marketing team. I had this whole Google Drive folder that was shared amongst the whole marketing team, where all our assets, graphics, letterheads, everything, every bit of content you might think a company needs was in there, and a whole lot of documentation around marketing plans, content I was writing, video sources. And guess what? Somebody in management, believe it or not,
right, because they usually have
one or two levels above me, I'm not mentioning any names, deleted a Google Drive folder, and it removed it for everyone. It synchronized destructively, and it didn't even ask them, are you sure? Didn't ask, just did it. Your wish is my command. Deleted everything. All of us lost a bunch of time, while we had our IT people immediately call Google and desperately ask them to restore it if they could. And fortunately, I didn't know this until then, they actually have backups and take backups.
I did not know you could even get a hold of Google to ask them.
If you're a commercial customer and you're paying enough money,
I'm a commercial customer, but I don't pay enough money.
Yeah. I mean, it probably depends on what products you subscribe to, right? But if you have a big company with a lot of data and a big Google Drive subscription, they're going to help you restore something, but there's a time limit. Like, if you go a week and then discover that you're missing that file because someone deleted it and it's synchronized, you're screwed. You won't ever get it back, because their backups are, at least at the time, I believe, they were rolling. They're not going to keep everything forever.
So I told you about, I was having layer problems on my, here, pull down the, are you done with the schematic? I was going to tell you a story real quick, or if we're still talking, but it's an Altium story.
Oh, sure. Go ahead.
So the story was, I got to the point where I wanted the layer drawing to be accurate in the DraftMaster or whatever it's called in Altium. Draftsman, thank you. And so I go in and I can't edit the layers, and I've checked that symmetry isn't checked or whatnot. It's got the default 4-layer board, and it's got like 2 prepregs, and they just add up all wrong, right? And I can't edit it. But so I went and I tried to manually rerun the wizard to set it to a default 4-layer. And I missed the message that said, yeah, we're deleting primitives on 2 layers. Well, I know what that means now. It deleted my work, right? And you didn't see the change.
Yeah.
I didn't see the change till when I did the file save, and I'm looking at a good board. I watched them delete it right as it's saving. So I did exactly what you said. I screwed myself. And, you know, I have a revolving backup here. I could have pulled it and everything, but I jumped on Altium 365 to a board that I know I liked, right? That where it added up right. Opened that and I popped out the .layer file, drug that over to where I was working and pulled in the layer file and was actually able to recover my primitives and the work. So that's I basically did a lobotomy on the fly, and I'm literally 1 day from release. It's, you know, these problems always show up when you're slated to hit go on the Gerber like at midnight, right?
Ah,
So yeah, I was real proud, but I jumped on Altium 365, was happy to find out I could download because I hadn't hit save to server, and I downloaded it and was able to you know, get the PC board file out, open it without a project around it, and extract a layer file from it, or create a layer file from it.
yeah. I'll tell you what, there's one universal truth for all humans, and different people have different degrees of this, but I know for myself, I am extremely loss averse. I don't know where that comes from. I
Yeah,
think
no, I'm
think some
freaking
of it's
paranoid. Yeah,
I think some of it's inherited. I think some of it is learned behavior from parents. My parents were awesome. I love them. And they actually did a fantastic job. There were 6 of us. I'm the youngest, and I gave them hell, but they're just awesome people. My mum and dad. But one thing, having 6 kids, and my dad was a teacher. He was a college.
okay.
He taught business and accounting. He was a certified practicing accountant in Australia. And he chose a college career because they had more kids and he wanted more time to do family things. So we had really good family vacations. We never had the money to go overseas or do anything fancy like that. But we always had beach holidays every summer, you know, like for 3 weeks. So they did such a great job. But in there, somehow I got adopted this attitude of scarcity, but it's a human thing. We all have it. It's part of the lizard brain, right? So maybe I just have a very highly developed lizard brain. The point of all that to say is I hate losing things, or things being ruined or destroyed.
I'm responsible indirectly through my company for loss of my customers' assets if I don't do my job right. So I'm paranoid times my number of customers times the number of things that can fail. And I had to learn how to sleep knowing all of that, because the more you know, the more points of failure you see when you look at something.
It's pretty anxiety inducing, isn't it? And it's like just not knowing where I stored a project on what disk.
Oh, I know that moment of panic where you go,
like,
and you try and recreate.
I need this thing right now, and I can't remember where I saved it. It's like,
and you have to recreate the thought process of where you would have stored it and go looking.
Yeah, I mean, so it's like it pays to develop early in your whatever work it is you do. Always develop habits of having a taxonomy and organizing things in a certain way. I know, like, software people and Altium's really pushing us hard towards, you don't need folders and organization and taxonomy.
You just need tags.
You just don't need taxonomy. You just need tax. That's right.
Put it all in one big pile.
Just put it all in a pile and search. Search is the key. It's like, no, it isn't.
What's up with Windows search? How come when I type 3 letters in Windows search, I get different results than if I type 4 letters, even though I'm still typing the same word?
Exactly. That's one problem. Search is not perfect and doesn't work a lot of the time. Let's be honest. I can look for something very specific and get all the other things they want to sell me instead of the thing I'm looking for. And I'm being real specific, and I might have to get to the 3rd bloody page before I actually find it.
Right.
So that's
Right.
one thing. Search doesn't give the results the user
It
wants.
gives the results they want to give you. Yes.
Exactly.
Yeah.
Learn. Second, if I don't know what I'm searching for, I kind of know, but I don't know the words or phrasing, right?
Right.
That's also a problem. That's why we need taxonomy and folders and organization. And damn it, sometimes I just want to freaking browse.
Right. Right.
So
And
Altium, I'm
sometimes we
also talking to
misspell
you.
things.
Don't take away the Explorer panel. I know you're trying to kill it gradually and you're boiling all the frogs, but I can't take it. Leave the Explorer panel and leave the folders in there.
Right.
And that's the other thing. When someone gives you something for years and years and years and it's there and you know it's there and you can have it anytime and it's just content, please don't ever take it away. I know you've got to pay for hosting, but it's really not that much. This was something that drove me crazy. They used to have all these marvelous templates for PCIe cards.
Yeah. Yeah. You're talking Altium now or who?
Yeah, I know.
Yeah.
I'm venting. They had a treasure trove of content in the
Templates.
vault.
Yeah.
Not just component libraries, not just components. They had templates
Right.
for all sorts of really good, like industry standard system on module single board computer outlines with the card edge connector, all predefined.
I grabbed an ITX off at one time and it's perfect.
ATX form factors. And what got me thinking about this was not Electron, it was it was the JP and his project with the Raspberry Pi 2040 or RPi Pico ATX motherboard project, which is if you haven't seen that, people, get on our Discord. Go to Coriolis-effect.com. There's a link at the top to join the Discord. There's a project thread, and you'll see all about it in there. It's a really cool project. There's a lot of others going on in there too. But flipping heck, like don't give people things like this and then take it away just because you think no one wants it. It's like just when they're looking for it, they won't find it and they'll be mad at you.
Right.
Anyway, as far as I know, all that stuff is still downloadable from the legacy web pages if you know where to find them. But I recommend to everyone, download it now while you can.
Yeah. So, well, I paid somebody a compliment this week. Was it this week or last week already? It was last week. Matt Liberty had lent me a jewel scope, which I've talked about before.
Oh yeah.
And I sent
2
it
weeks
back.
ago.
Yeah. Whoop, you locked up. We lost you. But I sent it back. Oh, there you are. You locked up for a second. What'd you say?
No, I said 2 or 3 weeks ago we had that in an episode. Go back and check.
Yeah. Well, and I bought one. He actually had to send it back to me, and he sent me a little note written on one of the PC boards. So thank you, Matt. But the biggest compliment I could give somebody is he had let me use it for free, and then a couple of weeks later, after I sent it back, I'm like, you know what? Give me one. And he got it to me in a day, and I used it that day. So it was it did exactly what I needed it to, which was look at current in a way that doesn't mess with the circuit under test. I needed to look at the input current.
And it goes up to a pretty decent frequency, right? 10 megahertz or so.
I don't know what frequency the bandwidth is of the response, but it's a great that it defaults to a DSO type of thing where I can look at real long-term events like a power on cycle, but then zoom into it incredibly and know that the auto ranging, like when you went from microamps to an amp, the auto ranging switched very quickly too, but I don't know how fast that is.
But it's still really,
really it well is. I try to live without it. I try to use the current output of one of my loads. I said, I need my jewel scope. So I wrote a check. So thank you, Matt. So, all right.
Yeah.
What else is happening around here?
Well, we're almost up at the hour here. Got 5
Yeah.
minutes left, and you're busy
Oh.
with contract today. But
Yeah, I was doing one other topic was designing for test, and I got this little thing from Adafruit, where if you had a row of these are pogo pins, and so they're spring loaded, and a lot of
yeah,
times you'll have that on a bed of nails tester. But a way to get around a bed of nails tester is a bed of nails clip on.
I love that.
Yep.
That's essentially that's a evolution of this thing I used to know of called plug of nails that was developed by
Okay.
this
Yeah.
really smart guy, and it's like a little he would make cable like JTAG cables to go to different standard off-the-shelf
Right.
JTAG things that people have, like the Sega J-Link,
She's got an ISP target, like it's a 2x3 connector. Same
and
thing.
you can get a keyed connector that will plug into the board, and the board will have two unrouted holes that it clips into so it can stay pressed in
Okay.
for bench use, or you can have it just press and go. So you can have someone on an assembly line, press it, hit a button, it programs, then it moves along, they get the next one, press it, hit a button, or even put that into a fixture that does it, in a completely automated way.
Right.
The
So,
plug of
and
nails.
that's where I'm at with a project for a customer is I'm now getting to testing it at front of line, assembly testing, make sure we're running good product, and then advanced testing for making sure we're selling good product. Those are different levels of testing now that we have to evolve through. So,
Yeah, that's cool. Well, that should be another episode. We should talk about test points and how
yes.
people do them. But
Right. And I had asked you, I said, do you use the Audium test point manager? And you were like, nope. And that was good enough for me because I looked at it and I had gotten burnt by it once years ago, and I wasn't going to mess with it unless you said it's the cat's meow.
It just requires far too much. It requires
Overhead.
far too much overhead to get it to work. It's just you have to set up 4 different design rules.
Right.
And you have to know what each and every part of those design rules exactly means, or it just won't work.
Right.
And then once you've set the design rules, you then have to go to that test point manager thing and have it examine the whole board and find all of the pads and vias that are untented that may agree to the design rules you've just set. And then it automatically sets them as test points, and it says, well, do you want one on each leaf node, or do you want just one per net? And it's like, well, why would you have one per net? Only for in-circuit tests and looking at signals.
Right.
What about bare board open short testing? Well,
we do that these days.
I've never needed to specify that.
Right.
The board house always just does
Nowadays,
it for me.
Yeah.
And they have tools built in their CAM workflow that it just happens. I've never had to think about it ever.
Right. It is a checkbox, like if you go to PCB Way or JLC PCB, but it defaults to on, and that's the 100% electrical test. And yeah, we're spoiled by it now.
And you want that anyway, because I think they do other things additionally, like if you have a lot of exposed, like non-solder mask coated area, like you might do for some power electronics designs, they can also put very high voltage. They can put 100 volts between one net and all the others. And if there's a hair whisker short or something, it'll just blow it off.
Yeah.
So.
Yeah, I've heard about that with like real bad whiskers, zinc whiskers and stuff.
Tin whiskers.
Yeah. Where they pop it off and it still doesn't work, and they do the same thing you just mentioned. It blows another one. There were so many whiskers that it had to blow them sequentially till it was good.
So this was the final badge. I just
that looks really impressive, Ben.
So the attendees. So I didn't design the 3D of this. That was done by the other guys in the team. But
still looks good.
They would do the final. The customers would do the final assembly. They would put the battery on. No, actually, the team ended up soldering those on because the battery headers came with the wrong component. But yeah, they would walk through the entire factory past from CAD all the way through to injection molding machines.
Wow.
And seeing the things come out and final assembly by robotics. And then here it is. Here's your badge. Go have fun with it.
That's cool.
That's
cool.
like, imagine the cost of setting up a trade show like that. That's what companies like Autodesk can do.
Right.
64 billion dollar market cap. I guess they can do that, huh?
Yes. Yep. So excellent. Well, we're at the top of the hour here.
Yeah.
And this was really interesting. Yeah. I'm not a coder, so my hat's off that you were able to pull all that off this week.
Well, but here's the thing. Now you have a little, there's an embedded system you can use if you just want to automate some tasks.
Right.
Like I could foresee using this even for bench instrumentation. I know there's better ways of doing it. I know that, but I haven't got time to learn them right now. If I wanted a microcontroller board that can automatically time different things and trigger different things on my bench when I'm working on something else, this might be a cool way to do it.
Right. Cool.
Just super easy. Basic logic, bunch of relays, no problem. Anyway. Yeah, thanks, Bill. It's been good to see you. I'm not sure if we'll stream again next week. Actually, I can tell you I probably won't be able to because I'll be at PCB West.
Right.
Until Friday evening. The actual trade show is on the Wednesday.
Right.
I may have some time where I can get some video on the show floor, and if I can, well, maybe I can post something about that instead. So yeah. So unless you and Mike or you and one of the other members on our Discord want to jump on together and show something off.
Oh yeah. Speaking of which, maybe we'll do that. We just got a new transformer. That's worth talking about.
Whoa. That expensive.
It was cheap because it's a video transformer, and that's kind of the whole point. You can pay $500 for an injection transformer, or you can buy a video transformer, and maybe
you don't mind dealing with 75 ohm instead of 50, right?
That's the only thing. But you know what? It's just a winding on a transformer at the end of the day, because it's about the ratio of the coupling, because it doesn't match the target in what we're doing anyway. So. Very good. So we'll catch you not next week, but we'll catch everybody on the Discord during the week, and we'll catch everybody here next time.
Yeah, enjoy your weekend.
Yes, and everybody have a safe weekend.
Yes.
Safe day and a safe weekend.
Yep. Thanks, Bill.
Take care.